What if one day the roads beneath our feet were no longer the primary way humans travel? What if the traffic jams that waste billions of hours every year simply became a problem of the past? What if your daily commute no longer involved sitting in a car surrounded by hundreds of other vehicles, but instead involved lifting off the ground and flying directly to your destination? For generations, humans have dreamed about flying cars. The idea has appeared in books, movies, television shows, and futuristic predictions stretching back more than a century. A world where vehicles move freely through the sky. A world where cities are connected not only by roads, but by invisible highways in the air. For a long time, this vision remained firmly in the realm of science fiction. It looked exciting. It sounded revolutionary. But it seemed impractical. Too complicated. Too expensive. Too dangerous. Yet today, something remarkable is happening. Around the world, engineers, scientists, aerospace companies, automotive manufacturers, and technology startups are working to turn this dream into reality. For the first time in history, flying vehicles are no longer just concepts on paper. They are being built, tested, refined, and in some cases, already flown successfully. The question is no longer whether flying vehicles are possible. The question is whether they can become part of everyday life. To understand why so many people are investing billions of dollars into this technology, we first need to understand the problem they are trying to solve. Modern cities face a challenge that grows larger every year: population growth, urban expansion, and transportation demand. More people means more vehicles. More vehicles mean more congestion. And more congestion means lost time, wasted fuel, increased pollution, and lower productivity. In many major cities around the world, commuters spend hundreds of hours every year trapped in traffic. Entire sections of urban infrastructure operate at their limits. Roads become crowded. Highways become saturated. Public transportation systems struggle to keep up. For decades, cities have attempted to solve this problem by building more roads, more bridges, more tunnels, more lanes. But there is one problem. Land is limited. Cities cannot expand roads forever. Eventually, space runs out. And when that happens, a new question emerges. What if transportation moved into a space that is still largely empty? The sky. Humans have always used the air for transportation. Airplanes connect countries. Helicopters provide specialized transport. But neither system was designed for daily urban mobility. Airplanes require airports and runways. Helicopters are expensive, noisy, and difficult to scale. What engineers needed was something different, something smaller, something quieter, something safer, something capable of operating directly inside urban environments. This is where one of the most important developments in transportation technology appears: eVTOL aircraft, electric vertical takeoff and landing vehicles. These machines are often described as the future of urban air mobility. At first glance, they look like a combination of several technologies: part drone, part helicopter, part airplane, and in some cases, part automobile. Unlike traditional aircraft, eVTOL vehicles can take off vertically. They do not require long runways. They can rise directly into the air from relatively small areas. Once airborne, they transition into forward flight, allowing them to travel efficiently across cities and regions. This capability dramatically changes how transportation infrastructure can be designed. Instead of massive airports, future cities may use compact landing hubs known as vertiports, small locations where passengers can board and disembark flying vehicles. Imagine stepping onto the roof of a building, entering an air taxi, and arriving across the city in 10 minutes instead of an hour. This is the vision driving much of today's development. But how do these vehicles actually work? The answer lies in several technological breakthroughs occurring simultaneously. One of the most important is electric propulsion. Traditional aircraft rely on fuel-burning engines. These engines are powerful but mechanically complex. They require extensive maintenance, they generate significant noise, and they produce emissions. Electric motors offer a different approach. They have fewer moving parts, they are more efficient, they respond instantly, and they operate much more quietly. This makes them especially attractive for urban transportation. However, electric propulsion alone is not enough. The real challenge is energy storage. Flying requires enormous amounts of power, much more than driving a car on the ground. Gravity is always pulling downward. A flying vehicle must continuously generate lift to stay airborne. This requires batteries capable of storing large amounts of energy while remaining lightweight. And this is where one of the greatest engineering challenges emerges. Modern batteries are improving rapidly, but every kilogram matters. A heavier battery increases weight. Increased weight requires more energy. More energy requires larger batteries, and larger batteries add more weight. Engineers constantly work to balance these competing factors. Advancements in battery technology may ultimately determine how successful flying vehicles become. Researchers are exploring solid-state batteries, lithium-sulfur batteries, advanced energy storage materials, and entirely new approaches to power generation. Each breakthrough brings flying vehicles closer to widespread adoption. Yet, even if the technology works perfectly, another challenge remains: safety. On the road, mechanical failures are serious. In the air, they can be catastrophic. This is why safety systems are among the most important components of every flying vehicle under development. Most modern designs include multiple layers of redundancy, multiple motors, multiple sensors, multiple computers, backup power systems, and emergency protocols. If one component fails, others immediately compensate. The goal is to create systems capable of maintaining safe flight even when unexpected problems occur. Some designs even incorporate ballistic parachutes capable of lowering an entire aircraft safely to the ground during emergencies. Because without public trust, flying vehicles will never become mainstream. But technology alone does not solve everything. Imagine a future where thousands of flying vehicles move above a city simultaneously. How do they avoid colliding with one another? How are routes managed? Who controls traffic? How do emergency vehicles receive priority access? These questions introduce another major area of development: air traffic management. Traditional air traffic control was designed for relatively small numbers of aircraft. Future urban air mobility could involve thousands of flights every day. Managing this volume manually would be nearly impossible. This is where artificial intelligence becomes critical. AI systems may eventually monitor entire transportation networks in real time, tracking every vehicle, calculating optimal routes, avoiding congestion, preventing collisions, and responding instantly to changing conditions. In many ways, the future of flying vehicles depends as much on software as it does on hardware. The aircraft itself is only part of the solution. The digital ecosystem surrounding it is equally important. Around the world, numerous companies are already developing prototypes. Some focus on passenger transportation. Others focus on cargo delivery. Some are building autonomous systems that require no human pilot. Others still rely on trained operators. Each company has a different vision, but all are pursuing the same goal: making air transportation accessible, practical, and efficient. Imagine how this technology could transform emergency response. A medical team could reach an accident site much faster. Critical supplies could be delivered to remote locations. Search and rescue operations could cover larger areas more efficiently. Natural disaster zones could receive aid even when roads are blocked. The implications extend far beyond convenience. Flying vehicles could become powerful tools for public safety and humanitarian assistance. But as with every major technological revolution, important questions remain. Who will be able to afford these vehicles? Will they become accessible to ordinary people? Or will they remain luxury transportation options? How will cities regulate their use? How will privacy be protected? How will noise be managed? And what environmental impact will large-scale adoption create? These questions do not yet have complete answers. But history shows that transformative technologies often begin with uncertainty. The automobile once seemed impractical. The airplane once seemed dangerous. The internet once seemed unnecessary. And smartphones once seemed extravagant. Today, all of these technologies are woven into everyday life. Flying vehicles may follow a similar path. Not overnight, not instantly, but gradually, step by step, year by year. As technology improves, as regulations evolve, as costs decrease, and as public confidence grows. Perhaps one day, future generations will find it strange that people once spent hours trapped in traffic on the ground. Perhaps they will view urban air transportation as completely normal, just another part of daily life. And perhaps they will look back at our era as the moment when humanity began opening a new dimension of mobility. Not across land, not across water, but through the skies above our cities. Because the future of transportation may not simply involve better roads. It may involve redefining what a road actually is, an invisible network stretching through the air, connecting people, places, and opportunities. A future where the dream of flying vehicles is no longer fiction, no longer imagination, but reality. And although that future has not fully arrived yet, its engines are already starting. Its prototypes are already flying. And its story has already begun.